Okay, here's where we're going to make a traverse. We're going to make a drawing of a traverse in ArcGIS Pro. We'll start with a blank template, a map template. We can name the project, just call it TravX. And I don't want to create a new folder, but I don't want to put it in that default location. I'll just put it on my H drive. I have a surveying folder here. Just put it there. Now I uncheck the box to create a new folder inside that. You can create a new one if you want. So it gives you a default topo map. I'm going to zoom in on the area that we're working on, and I'm going to change the coordinates of my map. This will help me choose the coordinates for the rest of the stuff that the points and the lines that I draw in here. So if I go to coordinate system and type in 2259, that'll be the area where we are for this particular traverse. Enter, there it is, New Mexico West State Plane Coordinate System. Okay, so at this point I have a surveying folder. In my surveying folder I have I'm looking for a white can that represents our TravX geodatabase. And there's nothing in it right now, but I also want to find the GPS points that we had uploaded from to a jump driver to the server from our Trimble controller. So it may be in here. It's actually in a different folder, so I'll have that folder connection. I think it's under H. Not there either. It's probably in this folder, so not sure where. Could be in this final one. Yeah, final traverse. That's what we named it. So I'm going to drag that into the map. And you won't see anything coming up here, but so I have to, if I look at the table, control double click on it, opens up the table, and I'll dock it up in the tabs. So I see that we have points A through G, and they have a northing and easting and elevation and, well, somewhat of a description, which is all null except for the base station, which we'll have to label separately if we want to label it at all. Anyway, so I want to display the XY data from a right click on that table or on this CSV file. And off to the right, we can just set what the X and Y values would be. We can put the Z in there, but we won't need it. And then I'm going to choose current map for the coordinate system, which gives us the correct coordinates. I'm going to do that twice just to be on the safe side. Never know with ArcGIS. So I'll go ahead and run it. Should see some points popping up here. Don't worry about these warnings. It's just that this panel is persistent, and it says it's already named something. I forgot to name it something better, but it really doesn't matter at this point. So I want to label these because I don't know how to draw this traverse. You can see the base station on top of our building, and then we have the points probably starting here and going around the building. But to be sure, I want to label them, so I go to the labeling tab, and I'll just click the label button on the left, and it's labeling them with the point values. I could label them with elevations or something else, but point is a good one to start with. Okay, so now I want to draw a line between each of these points. So I'm going back to my catalog, and in that geodatabase we can see that we have the points. All I'm going to do is add a new feature class. So we have a points feature class in there, and now we're going to make a line feature class, and we'll name it, we'll just call it courses. And I'll go through this wizard, and this allows us to add fields here. We'll add fields later, so I'm just going to go next. The coordinate system, again, we'll just choose the current one. And next all the way through, there's no other changes really to be made. Okay, I'm going to refresh this geodatabase, and I should see the courses in there. I'll add them to the map. And now I can start editing and drawing on this layer. So I have a points layer that's already been populated, and this courses layer, which is lines. And I'll go to the edit ribbon to do this. Click on the create. It'll ask me, basically on the right, it doesn't really ask, but you need to click on courses, and then we have this line tool that allows us to do that, to draw on the map now. I also want to make sure my snapping is on, so it is, so I can snap to points. So if I get close enough to this point, I can see that I'm snapping to it. So I'm going to click from point A to point B, and then you can come down to the little menu bar down here, little toolbar, and finish. You can also notice that F2 will finish it for you, so you don't have to move your cursor so much. So point B to point C, F2. If you don't do the F2 and finish each line, then one line will be between 2 points, and that's not what we want. So just be sure to hit F2 between each point and finish it off. There we go. At this point, we can open up our courses. Well, we have to save our edits here. Save the edits, and I'm going to control double click on courses, dock the attribute table, just want to see what I'm looking at. It already gives me a length, which is nice, but I also want to clear the selection. I'm going to take this layer and run a tool on it to add some more fields that are necessary to calculate the direction, and if there were curves, some radii and things. So if I want to go to Tools, I'm going to go to Analysis and Tools and Toolboxes. I'll just search for COGO, Coordinate Geometry, and this is the tool I want, is to enable the feature class to add COGO attributes to it. So I'll click on that tool, input line features, courses, and this is all I have to do, and I'll run it. And now it's added a direction, a distance, which is going to be the same as shape length, but it'll be all right, and some radius and arc information, so that we won't need. At this point, we can select all the lines or courses by dragging, clicking on the first and dragging down to the last on the gray box to the left of the Object ID column, and that selects them all. I can see my map that I have them all selected, and they're in cyan color. Let's go back to the table, and now back to the Edit ribbon, and pulling this list down, there's also some COGO area in some of these common tools, and one of the common tools is Update COGO. So I'll go ahead and click Update COGO, and all these settings are just fine. So I'll update, and now it's given me a direction, a distance, and of course there's no curvature. Well, that direction is obviously an azimuth. I'd like to maybe redo that with using like a bearing and a distance, compass bearing, I mean. So as we're going to label them with a compass bearing and a distance. So If I click on this button near Manage Edits, I can change my units here. Angular units, I can choose, right now it's on decimal degrees, so I want to change that to DMS, degrees, minutes, and seconds. And also in the direction units, instead of using, well, it's on quadrant bearing already, so let's just see what that does. I'll re-update those, and it's not going to change. So that seems to be a problem with ArcGIS Pro. You used to be able to change your units, and maybe there's another way to do that. But we can manage with this by adding our own columns and calculating the bearing on these. So I'm going to save my edits. Now I can click on Field, and I'm going to add a north-south field. So I can't use funky characters, so I'll just do north_n_s, and that's going to be text. And I want the text to be, it doesn't need to be very big at all. The degree field, that's just a short integer. The minutes field is also a short integer. The seconds field, I would like to have it have one decimal place maybe, as we won't really need it, so I'll just call it a float. One more field for east-west, and that's just going to be a text field, and we'll make that 5 also as max length on that. Okay, so let's save those changes to the table. Once that save's done, I can close that fields panel, I guess, and now I have a area where I can calculate the compass bearing information. So let's start with the north-south field and calculate whether the thing's north or south. I'm going to need to use like an if statement to make this work, so let's calculate the field. So over here, this is good for labeling, so I do want to label it with my bearing. So when is it going to be north or south, right? So I'll use a code block here to put a little if statement in here. So let's just call this just call it lowercase north and in parentheses, and I just want the direction field to be used in calculating this and using my if statement. Okay, so in the code block I'm going to define north with a dir for direction. So that's going to be the value that's passed down from the direction field. I could have named it anything. North and dir are just arbitrary-ish sort of descriptive variables that I chose. So the if statement would be, well, if dir double equals, that's a test. Instead of setting it equal to something, I'm seeing if it is equal to it. So I use double equals, and if it's equal to like well, not actually, if it's, this is a number, so if it's basically less than 90 degrees, I was getting to my labeling already, but, or to see which direction I'm going, I need to see if the direction is less than 90, but also if the direction is greater than 270. I know it's north if that's the case. So what am I going to do? Return capital N. And then I'll type in an else. What am I going to do if it's not in that? Well, then it must be south. So I'm going to return south. Okay, that should be, actually I need an or in here instead of an and, right? So if it's less than 90 or if it's greater than 270, it can't be both, so and would have given me all souths, I think. So check the expression for errors and let's run it. So it looks like it did it, and here's 344 degrees azimuth, and that's north. 277, that's just barely north. 7 degrees north and north. And these other ones are south, and 283 and 286. So a lot of them are north, 2 of them are south. It seems like it's a good one to do. Looks like it's working, in other words. So I'm going to try the east-west field next. By the way, we're using Python as our coding language here, our scripting language. So I'm going to do pretty much the same thing whether it's east or west. So I'm just going to type in east for my, just to be, and I'm going to still use the direction field as the values. And so this time I'm testing, all I need to do is test one thing, right? So if it's less than 180, it must be east. Otherwise, it must be west. So almost the same kind of if statement, but just making it east or west. So let's run that. And now that I've changed, it doesn't look like they're all, oh yeah, I bet they are all west. So none of them are less than 180. So that is true. So if I look at my map, every direction is pointing west. So for a second there, I thought we had done something wrong. Okay, so now I need to figure out now I can use the direction here, the north, south, and whether it's north or south or east or west, to figure the azimuth and convert that to a compass bearing angle. So we've gone over this before in another lesson, what to do, but we're going to just alliterate to it now. So now I'm going to calculate the degree field based on direction, but also now that those are populated, I'm going to type in a comma here and use my north-south field, the comma, and the east-west field. So now I'm using direction north-south and east-west fields. So we're going to call this DEG for degree. So we're going to DEF, define the degree, and we're going to use DIR for the direction values. I'll just NS for the north-south and EW for the east-west. That'll keep it kind of straight. So this next thing is it also needs an if statement to see if, well, if it's north or south, right? So if NS is equal to north, then what am I going to do? Well, I still need to check if it's east or west. So if it's north and embed the if statement in here, if EW double equals an E, let's try, then what am I going to do? At this point, I know I can return, it's northeast, then I can just return the direction. But I can't just do the direction. I need to use a trunk function, so I have to type in the math. And that can be found in this list, actually. If I look at the math various, I'm using this math trunk function, or method, if you will, and I'm going to truncate that direction just directly. So if it's less than 90, basically, it's going to be, the azimuth would be in the northeast quadrant, and the azimuth would be the same as my compass bearing. Okay. If it is not east, it's still, so it's still north but not east, then I would return what I would have to do to I would still truncate that value, but I would have to take 360 minus my direction. Okay, that's a little long, so I'm going to give that a little more room. Okay, so if we're northeast, I just use the direction, I truncate it. For the northwest, I take 360 minus it and truncate it. Sounds pretty good. So now I need to go backspace. Now this indentation is very important, so I need to stay in line with the original if statement and embed, well, set up an else condition for that, for if it's not north, in other words. So if it's not north, what am I going to do? Well, I'm going to copy this if statement. I got to just check it again. So I hit return and then paste this next if statement here. And if it's east, then I return, well, I don't want to return just the direction, so this would be southeast. What do I do if it's southeast? Well, that means it's less than 180 but greater than 90, so I'm going to take 180 minus that direction and truncate it. And furthermore, if it's southwest, then it's a little bit bigger than 180. It's between 180 and 270, so I take the direction and subtract 180 from it. So that should give me the compass bearing in all 4 cases. So check for any errors and run it for the degree field. And it looks like it's working pretty well. I can check a few of these numbers, such as the first one, 344, that's almost 345. And you can see that my direction is, my compass bearing angle would in the degrees is 15 and some change. And so that's where the minutes and seconds comes in. So that's next. So minutes gets a little more complicated. I'm going to basically do the same thing, but instead of just pumping out the whole number direction, I need to truncate. I still will truncate, but I'm going to add a modulus. So that's another math.f for float mod, and I want to take the direction modified or modulus with divided by 1. So I'm going to take that as if I were dividing it by 1 and take the modulus of it and then truncate it. So I need another parentheses. So that's what it is. But before I truncate it, I still need to multiply it by 60 and then truncate it, and that'll give me my minutes. So this math m mod right there divides the direction, the azimuth, if you will, by 1, takes the remainder, the decimal value, multiplies that by 60 and truncates it. So that's what I'm going to do with the rest of these. So I'm going to truncate this math f mod. I'm going to put the 360 minus the direction in parentheses, divided by 1. Finish the f mod, multiply it by 60, and truncate it. Again, truncate the math f mod, divided by 1 times 60. If I count my parentheses, I have 3 right-facing ones and 3 left-facing ones, so I think I'm okay so far. And finishing out for the southwest portion of it. That should do it. So let's run that for my minutes field. See how my minutes come up. And we can check that when we're done here and see if we end up with the similar remainders here. So far it's looking pretty good. We can do some just random checks on that, but I think we're pretty good on that. Okay. So to save you all the typing again, we do want to explain the seconds field. It gets a little more complicated. This is the most complicated it's going to get, but it's generally the same, but there's no truncating going on here. So actually I'm going to just take that out and just leave the math f mod there, and I'm still multiplying it by 60, but what I want to do is just subtract the M field. So I need to add that M field, the minutes, now that I've calculated the minutes. So I'm going to put an M in there. I'm kind of doing this backwards. But, so now I'm setting this, I should call this seconds now. Just to keep it clear. I might want to save this actually. You can save this sort of complicated, lengthy little embedded if statement for it. So anyway, seconds using the direction and the north and south, east-west columns. And now I'm passing through the minutes, which is just the whole integer value of the minutes. So I can just subtract it right here from just what I had calculated before, the mod of the direction divided by 1 times 60. That's the decimal minutes, if you will, and I subtract the whole minutes, and that just leaves me with the remainder of the minutes multiplied by 60. That just gives me the seconds, and that's all I'm after here. So take out the trunk in this one, and we'll just finish it off this way. So after I multiply by 60, subtract the minutes from it, and multiply by 60 once more. So ultimately I am multiplying it by 3600, the remainder part of that decimal degrees. So let's finish this off here. Minus my minutes times 60. I encourage you to make sure you're straight in your mind about that, because it's actually quite interesting in my opinion. Okay, let's check if we have any errors, and let's run it. Now I'm going to get a bunch of decimals on this as I am expecting to, but that's okay. In the labeling we can round that off. In here the rounding isn't as easy, and I've already gotten it kind of complicated, so there we go. Now we have all the bearings ready for labeling. Let's go to labeling now. So in this, well, I can keep the table open. I think it'll be just as easy. And I want to, I'm going to label them all the same way, so I don't need to set up a class or anything. So I'm just going to click on this label expression and just start off with a couple things. When I start an expression, everything is cast to, well, with Python, I'll need to set this as in advance, where I just need to, everything is cast to text basically, so sometimes I have to change it back to a number to round it and things like that. So here's where I'm going to start at the end. So I'm going to turn it back to a string after I round it, but I can't round it unless it's converted back to a number, which is kind of silly. And then this is where I get my distance. So I actually want to use the distance that it calculates, even though they're the same. So there's distance, and it's in square brackets. I'll leave those on there. So I'm just going to float distance, and I'm going to round it to 3 decimal places, and then end the parentheses, and then I'll just turn that back to a string, and I'll return that value. Well, that's the distance, and now I'm going to add a foot tick, I guess, to it. So that's a backslash apostrophe, and I'll put that in quotes. Let me make this a little longer. It's going to be a fairly long expression here. So backslash apostrophe and double quotes, and I put pluses in between everything. So the next would be a line break, so that's actually a backslash lowercase n. I'll put that in single quotes. You can use single or double quotes actually. So there's my line break, and then the next thing I want to do is my north-south field. So I'm just going to double click on that, and then add a plus to it, and then the degree field, but I want to add the degree symbol to it, and so this one's a little weird. So that's going to be a \N, and then in squirrely brackets, or shift square brackets, if you will, I type the word degree sign. So the degree sign, and that's in double quotes. So that'll give me my little degree symbol, and then I'll put the minutes. I'll add a plus between everything, and after the minutes, I'll put another apostrophe, so that's a \apostrophe in double quotes. Single quote, double quote, there we go. That should work. And then this is where I have to round, so I need to use a string to go from round the float, so similar to what I did with the distance. So float, let me make this a little longer so we can see. So what am I floating? I'm floating my seconds field. So don't click that. So I float the S field, and then I actually need parentheses around that. So I float the S field, and I round it to 1 decimal place for the seconds. That'll be good enough. And then I turn it back to a string. Okay, and in double quotes, I'm going to add and squirrely brackets quotation mark. Yeah. And that in double quotes. So that'll give me basically a double quote. It's called a quotation mark. And the last bit is going to be my east-west after the seconds. Let's see if I have any mistakes in there. Okay, here we go. I need to uncheck advanced. I don't need to, this can all be done just right in the expression field, sorry. So I'm going to apply that, and looks like I'm getting the distance and the bearing nicely done. However, it's not on the line, so the positioning of it can get a little tricky. So let's look at the position of this as far as placement goes. Regular placement, I think that's probably okay. I just need to offset the positioning of it. So if I just lower that value down, probably the same amount as the font height, then should be getting a pretty decent look at it. Okay, so then what I'd like to do is just label the points a little bit better. So let's look at point labels. I don't want to put point in front of it. I just want like the A, B, C, D. I could leave the SGC base the way it is. So I'm going to make another class. So create a label class. And this will just be, I'll call it base, where it just labels the base. I need to make an expression for this base so that it's where the point is equal to just SJC underscore base. So point is equal to SJC underscore base. Yeah, I could have just pulled that down, huh? Okay, and apply it. Okay, so back to the map. It's being labeled SJC base right now, but I'm going to change that to just in quotes. How about just base station? Okay. And apply. Okay, I'm getting 2 labels here because I need to change my class 1 and change the expression to where the point is not equal to SJC base. There can be all the other ones. Okay, now for the expression on the points, I really just need to, I just want the one character out of it, right? So as far as my, well, I'm going to use Python again. In this case, I'm going to use advanced here, and that way I can strip, or I can what's called slicing, where I can just return the well, I need to make, I'll just call that slice for SL for slice, and I'll just make that equal to the value in the point field, and then what I want to just return is the SL variable sliced though with bracket, and I just want the I would say it counts at 0. The count is 0, so I don't want the first 4 or 5 characters, so 0, 1, 2, 3, 4, so just the 5th one. So if I just put 5 in brackets, it'll only give me the 5th character, actually the 6th character starting at 0 anyway. So I'll apply that, and now I just get the letters for the points, and I think I'm pretty much done at this point. I can change the color and the size of the points and things. Just turn off the topo map, and now all I need to do is lay it out. See, this kind of goes away if I am zoomed out far enough. So I think I just want to add a layout to this map, and we'll be done. So insert. Probably be a good idea to save it at this point. And then new layout, and I think maybe a B-size landscape would be nice. So architectural landscape, let's try, actually not architectural, how about ANSI? That's a 11 by 17. We'll probably just export these to PDFs, but the scale will be better. And so I'm going to insert a map frame at the current scale, and we'll just scale in a minute. It's a nice big long map here. Okay, well, the zoom level is not great, so I'm just going to right click and activate it. This way I can pan with the middle mouse button and get a good scale. If I look at the scale down here, I don't know if I can go to 1200, which would be 1 foot is 1 inch is 100 feet. Not quite. So I'm going to have to go 200 feet, which at that point I can just use a, let's kill that layout and just add a different layout. Just a letter size then, if we're going to go to that scale. And insert a map frame. Again, just using an A-size piece of paper. And at 2400 scale, activate it so I can pan. Yeah, that label's not showing up so well, so might need to, I mean, it's looking pretty good except for that one label. So, under labeling, you can change the font of these labels just a bit smaller. We could go 1/10 of an inch or even 8-point font, and there it's showing up. Let's just call that good. So at this point, we just need to go to the insert ribbon and insert a few in the layout. We'll insert, we'll go back to layout here. So we're back to the layout itself, and we can insert a north arrow. Scale bar, don't really need a scale bar, although there are a lot of them. Some scale text would be good. So under dynamic text, we can do a relative scale, and I'll just put that right under the north arrow here. It's inches equals miles, but if I go to properties here and look on the right, I can change that to feet. But I got to make it feet instead of miles here, so I'm going to set that MI to FT after clicking on that button, and that'll be 1 inch equals 200 feet, just what I wanted. And maybe that equals should be an actual equals, so that would help. Okay. Add some text, just basic text, paragraph text, just down at the bottom for your name and date, and we'll export it. So today's the 13th. Okay. Other information would be necessary, such as where the point data came from and such, but this is going to suffice for our project today. At the end of it, we want to export it. So if we go to the Share ribbon, we can export this layout, and we can use a PDF if you want to turn it in electronically, or at this point you could just save it in a place where you want it, or just print it. So that concludes this video.